Hi everyone, welcome to this talk. My name is Vadim Ogievetsky, and joining me here today is Matt Armstrong from Confluent.
Hey, Vadim, good morning. Thanks for having me.
Good morning, Matt. So today we're going to be talking about observability and what's happening with that in Confluent. Matt, why don't you start by telling us a little bit about yourself first?
Yeah, absolutely. I'd be happy to. I think my official title is really the lead of the Observability and Data Platform team here. But those are kind of like overloaded terms, I think, in our industry. And so it might be best to sort of characterize how I got here and maybe a little bit about some of the history of, I think, what landed me into this particular team and this particular role. About 10 years ago, back in those days, we didn't even have terms like observability. We hadn't necessarily stolen those yet from the rest of industry. And so we were focusing on building essentially support efficiency tools back then. And so I was at a company where we were building systems that would support telemetry collection from these storage arrays that we had out in the field. And we would use that telemetry to essentially automate and sort of make the support process more efficient. Over time, we eventually realized though, that we could start tapping into that data and provide product differentiation through, actually applying data science to that data set and, coming up with things like forecasting and latency attribution and all these cool things that at the time were sort of game changing. But over time, the kind of industry evolved, and as we all know, the motion to kind of move things to cloud started, and so the world of observability changed. And I think in some ways became somewhat different, as we know, but it also became more complicated and certainly more front and center. No longer about support efficiency. It really focused on how we think about running the business from the perspective of the cloud. And so that involved, starting to support consumption-based billing and starting to support these hybrid cloud use cases and, starting to drive towards outcomes rather than just raw data. Customers want to build applications, not, simply just operate a piece of infrastructure. And so observability became more and more prominent. And coming here to Confluent, it's sort of like the culmination of all those things, but we also have some interesting additional complexities here. Here we really care about using observability to drive, autonomics. So it's not just like billing and support efficiency and some of the internal observability that we were all used to. We're actually trying to automate our systems so that we can run them more efficiently, securely, right-size them, and things like that. We also have the requirement, because we are providing infrastructure to other companies building software, we need to be able to allow them to monitor and observe Confluent. And so we have to provide pretty high velocity, high cardinality data to our customers. And then a really interesting thing here at Confluent is that there's sort of a meta goal in what we do with the observability team. Observability is obviously a big data consumer, a big data producer. And so we are one of the most important meta customers in some sense for Confluent, because a lot of what we do helps drive product development for Kafka and for the adjacencies and the ecosystems around Kafka. And so, we work a lot with the teams building connectors, and we do a lot of stuff with the K-Streams team and the K-SQL team. And all this really kind of creates, in our minds, sort of the best of breed solutions for our end customers as a consequence.
That's really awesome. It's really interesting to hear also how you're kind of like one of the biggest meta customers yourself. That totally makes sense, because obviously you want to observe everything, and Kafka and Confluent are such a great platform for collecting all of that, all of those metrics and using that for observability. I'm curious, as you kind of came into Confluent to lead observability, what database requirements did you have for serving?
Yeah, good question. It's one I was reflecting on Jay Krepp's keynote at Current from a month ago or two, and he essentially was talking about how there's a little bit of a chicken and egg problem, and often with innovation, and I was thinking about how that's sort of applied here. I think some of the use cases that we talked about previously and some of that initial phases of the term observability might have been actually constrained by the technology set we had at the time. And so initially when we started off doing this kind of stuff, a lot of what we were doing was batch based, and in fact it was in many ways harder than that or worse than that, because we were taking these human readable outputs and trying to run them through lots of grammar in order to make them machine readable and relational and something that we could reason about. There was high cardinality, and so we were sort of the early adopters of like a lot of the big MPP paradigms, but at the same time the latency requirements weren't as high, and the expectations from customers on what we could do with the data were somewhat low. People were impressed with anything. But like I said, as things evolved, right, those requirements have become more and more strict. We still have high cardinality data, but we have an additional constraint in that we can't really necessarily separate it out or split it into multiple data sets. We also have these challenges related to like data ingestion. We need to be able to pull in stuff, very quickly, very efficiently. We don't really want to deal with a bunch of like cardinality reductions up front if we can avoid them. And so all these things sort of place, stricter and stricter requirements on our databases. And so, years ago we were working with some of like the modern cloud data warehouses, which purported to solve the problems that we had in the old MPP paradigm by eliminating the need for like these, teams and teams of DBAs and infrastructure engineers to support this stuff. But as probably a lot of people are familiar with, the cloud data warehouse, sort of being a Swiss Army knife in a lot of ways, also comes with some constraints around cost, and there's some operational complexities that are a bit more opaque, and you end up dealing with not just the three big V's or big V's of big data, but also like the big dollar sign association. And so, cloud data warehouses are obviously a big step up from the MPP paradigm. But here at Confluent, we have all those constraints, plus the need to support real-time analytics. And so I think that's the big differentiator between, the things we've done in the past and what we're doing here. At Confluent, our ability to serve real-time decisions is like a huge component of what makes us, competitively differentiated. We need to use everything from, simple thresholding and kind of like, alerting criteria all the way up through like anomaly detection. And this is really critical when you think about what we're trying to do with the data, which is not only drive like, notifications and sort of insights into the data, but also like this low hysteresis automation, wherein when we see something, we can react to it and then observe the consequences of that change right away to determine if they're working or not. And so this stuff is all really, really critical, and obviously places sort of a new constraint on what we would choose for like data systems technologies. Paradigmatically, though, we also needed this whole thing to be familiar with like the rest of the use cases we have, because as a company, we still have, customer success teams and customer support teams and our own engineering teams in the context of escalations, needing to tap into this data, sometimes fairly ad hoc, right? We need to be able to look across things that we may not necessarily have, sophisticated automation written for yet. And so, as probably to the surprise of nobody listening to this, we use Druid for all of this, and it's really been quite successful for us so far.
Yeah, so I guess your stack kind of looks like you have your Kafka, probably you're running it yourself on Confluent Cloud and feeding it into Druid. So I'm curious, how has Druid helped you meet the goals of the requirements that are always getting higher and higher from your customers?
Yeah, no, it's a great question. So you're right. The stack is essentially that we have. I mean, we have a kind of a rich and complicated collector landscape because we're dealing with collecting data from lots of different sources. Some of them like native vendors, some of them, our own code, and so we have to have a lot of, ways of sort of thinking about pulling that all together. But it does land in Kafka, and I think that's the case with many teams dealing with big data in one way, shape, or form, whether it's even batch or real time, is that Kafka's sort of at the head of that pipeline. That's true for us. And then, we pull it into Druid almost immediately. And, like I said, there's some really strict and interesting goals around why we have to, pull this stuff into Druid and be ready to serve it right away. But a lot of them come down to just customer expectations. Kafka is often a very critical part of people's infrastructure. And, if you were a customer buying Confluent, you would want to know the operational characteristics of your environment, not an hour delayed, right? You can't look at your data from, yesterday and make a prediction about what's going on right now. You need to see it almost in real time. And so Druid is able to do that for us without a whole lot of like operational complexity or overhead or connector lag or, doing a lot of gymnastics to get that data ingested. And so that's been really, really, I think probably one of the most key dimensions why Druid was like the first natural choice when this team was started, when Confluent Cloud was being kind of envisioned and incepted. But beyond that, we're like I said, we're doing a lot of stuff related to multiple use cases, multiple people tapping into this data. And so Druid has been quite extensible and quite flexible. We do a lot of things today that we didn't probably imagine 3 or 4 years ago. And I think that, like I'm sort of approaching this from an engineer's perspective, but I think if you were to step into the shoes of a product manager, you might think of Druid basically as being able to empower like essentially a great product and a great piece of infrastructure with a great support experience today, but perhaps more importantly, really an unconstrained future. We can sort of look ahead and say, hey, if we choose to embark on a lot of different, paths related to, AI ops or, applying ML or, doing anything on top of this data set, we don't have to sit around and concern ourselves with whether the foundation has been built correctly. And I think that's been one of the most interesting dimensions of thinking about how Druid fits in.
So we see a ton of companies marrying Kafka and Druid together. I think, in my experience, it's almost like a coin toss that a company will be sourcing its data from Kafka from the people I talk to. Um, and I'm just curious, like, what do you think was Druid's uh, value to the Kafka ecosystem and uh, like to the Kafka community at large?
Yeah, good question. I mean, I think beyond being a great platform, Druid has kind of a natural set of characteristics that make it sort of in some sense, a natural fit. It's part of a broader streaming ecosystem. What I think we've all come to learn about Kafka, as I mentioned earlier, is that it's essentially everywhere in most data pipelines. And even if those pipelines are kind of traditionally batch-based or have large DAGs of different steps where they go through and ultimately dump their data out to some other data store, Kafka is there. And I think as businesses sort of mature and as the customer expectations of that platform increase, naturally there becomes a tendency to sort of seek out an end-to-end streaming solution that involves Kafka at a foundational layer and then something on top of it that can be streaming native. And I think Druid being streaming native is really probably one of the key reasons why it gets selected so often as a pair or a complement to Kafka. In traditional or previous paradigms, we would spend a lot of time kind of working around some of the constraints of our database or our data warehouse. We would be waiting for, kind of traditional load or ingest processes to complete. With Druid, that is essentially instant. We'd be putting in places like, these kludges or shim layers to sort of give an illusion of stream processing. Again, with Druid, the data is accessible as soon as it arrives. And so I think that, that native kind of end-to-end streaming paradigm is sort of baked in, which makes it, a pretty likely pair. But I think it goes even further than that. Like we work with connectors a lot here at Confluent. Connectors are a big part of what makes Kafka successful and an easy sort of component to integrate with or to other downstream systems. But I think the native integration that Druid has with Kafka is really preferred in many ways over a connector. Obviously, if you're an engineer or you're thinking architecturally, it's more elegant, it's typically more efficient, and it generally speaks to a system that's sort of designed to kind of think in the same paradigm as the upstream that it's working with. And so that's been really, I think, important for us. And these two things together, I think, enable you to really see how Druid, at least in the case of a lot of teams, including ours, to really kind of be, like I said, that obvious complement to build a great data platform to do the kinds of things that we need to do here. Yeah.
Yeah, I know you guys have built a ton of connectors for Kafka for everything, and it's my hipster take on it is I remember that we had like a native Kafka integration before it was like everybody and their dog had one. It was really cool, and we still continue to evolve that to make sure that it's absolutely best in class. Because as I said, I think for us, like about half the people we see, they're like going to be consuming data from Kafka, and for the half that aren't, half of those are probably interested in moving to a streaming solution, and they're just starting at the user's end and kind of working their way down versus like the other way around.
Yeah. Yeah,
Um,
definitely.
So I'm curious, what's next in your mind for the future of observability at Confluent, and how can Druid help with that?
Yeah, let me answer your question kind of in two ways. I think there's sort of, what's next for observability at a place like Confluent, and I think there's sort of what's next for observability, as a sort of an industry more broadly. I think from my perspective, there's a lot of broader applications of the data set, the same data set that is used for a lot of, traditional monitoring and what we call observability. And this goes beyond, what I would even call like the customer 360 or kind of internal customer insights. I think that a lot of companies, including Confluent, are looking to do like, deep customer analysis, recommendations, really become embedded partners with our customers by understanding what they're trying to do and how their product or, our infrastructure underpinning their product can be used to achieve that outcome. And so a lot of those insights can be generated and even inferred from the telemetry that we have. The other thing is, I think, related to that, and this is a big difference between what Gartner would describe as like vendor-driven AI ops or domain-agnostic AI ops. is that a vendor like Confluent using observability as a product differentiator has the ability to look at cross-customer insights. We can infer what normal is, we can infer what optimal is on the basis of looking across a large install base of people and saying, hey, this is sort of traditionally a better way of doing these things, or this is a better way of configuring things, or here's how you should be thinking about your sources and sinks. And so being able to give that prescriptive guidance to customers, especially those that may not be as kind of like technically native customers, is really critical and important. I think more broadly, people are looking at observability data sets as doing things outside of just operational monitoring as well. So I think the other interesting use case for the observability data set, and I'm seeing this increasingly in my conversations with peers and other industry experts, is the application towards security, intrusion detection, things kind of related to operational behavior of a piece of infrastructure that may not be necessarily about problems with that infrastructure or just simply resource constraints and things like that. And if you think about it, it makes a lot of sense because security intrusion detection and things like that, these are similar problem spaces. They're dealing with unknown knowns. It's a circumstance where you're trying to look into a big data set. You know there's risk in there. You know there's probably behavior that is anomalous, and you're trying to pull that out of the noise, and you're trying to do so in a low of latency way as you can. And so that's quite difficult, but I think something that's becoming more and more popular as the tooling catches up to enable those sorts of things. I think beyond that, though, beyond just the broader applications of the data set, there's also sort of an increasing expectation of how we democratize observability. And this is something that we saw early on with sort of the support efficiency use case. We have subject matter expertise everywhere within the company. Often these users or the experts, though, are non-technical. They don't necessarily have the same engineering chops that say your core Kafka engineering team would have, right? But they have deep knowledge of how the system should operate. And so giving them the ability to tap into that data and starting with something like an exploratory engagement that eventually turns into them being able to codify their knowledge into the system, and ultimately, ideally, being able to even automate those reactions to those those detections is something that we want to be able to do. And sort of opening this up and being able to basically unlock observability for your broader company is I think a really important thing and something that we see more and more demand for. Obviously, you're always going to have infrastructure pressures. Like I said, you always have your velocity, your volume, or variety problems to deal with. But I think cost is a big dimension too. Here at Confluent, we're dealing with a fairly large data set. I think we're in the something like multiple millions of events per second of data that we're pulling into Druid. Doing this in some of the older paradigms I spoke about would be horrendously expensive. And as a matter of fact, in those eras, we would have to often throw out data or do these cardinality reductions on ingest to be able to sort of operate, with any sort of margin that mattered to the business. And so, I think from that point of view, being able to come up with a system that not only can scale, but can scale efficiently is a super critical requirement. And it's something that we're just going to get more and more, stress and constraints around as time goes on. So I think, how does Druid fit into these? The name, right, as we all know, it implies kind of the notion of a shapeshifter. I think the thing that often kind of gets missed with that, and this is just my opinion here, but it is really the idea that a shapeshifter has to be kind of, one or the other, that it has to be in kind of a mutually exclusive shape, if you will. And I think a lot of the time what we're finding out is that our use of Druid doesn't necessarily paint us into that corner. We're able to support both real-time analytics as well as historical queries within the same platform. We're able to use it as an application foundation, also as an exploratory data store for ad hoc querying without having to think about a completely different access path. And generally speaking, just that integration is so easy for us. It's very easy to get data into, as we talked about, because of the native Kafka connector. But it's also really easy to get data out of. I've worked with a lot of other systems in the past, and you'll have these teams of people that have deep idiosyncratic knowledge on some particular tech stack, just to be able to create your access layers or your ingest layer. And so I think from that point of view, Druid has just definitely a competitive advantage. We are a big component of, I think, the Druid community. Here at Confluent, we're one of the biggest Druid installations in the world. And so obviously we're really excited to see what's next and to partner in that too.
Absolutely. I think what you pointed out of having the events that are being collected and aggregated, the events themselves being each individual event being like of so little value, but the aggregation of that making sense when you can scale to such huge amounts. That has been really like the defining I mean, the reason for Druid's existence, really, and in many ways also for Kafka as well, because people want to actually collect those events, and Kafka is the best way to collect and stream them across your system. So very excited for to see this vision become fulfilled and see how the space develops. Thank you so much for the conversation.
Yeah, absolutely, Vinny.